All right. Looks like we have Algebra 2, Lecture 1116 through 1118, just before the Thanksgiving break. OAS A2A22, the student will perform more operations on functions. Today we're going to do multiplication and division, multiplying functions and dividing functions. We'll give you an idea of what it will look like on your standardized worksheets. So here we go. We're asked to perform the indicated operation. We're given a g function, g of n is equal to n plus 4, h of n is equal to 4n plus 4, and we're asked to find g times h of n. That's another way of saying that you might see is g of n times h of n. You might see it written like that. They both mean the same thing. With that in mind, here's what it looks like when we do it. I'm looking for g times h of n. That just means I'm going to take the g function and multiply it by the h function. Now that's a binomial times a binomial, so I'm going to have to FOIL. That will be n plus 4 times the quantity, 4n plus 4, scooch this over to the left a little bit. There we go. And that will give us g of n times h of n. And now I'm going to FOIL, combine like terms, and I'll be looking at the product of those two functions. So here we go. Going to take this first term and distribute it. FO, multiplying as we go. N times 4n is 4n squared. N times positive 4 is positive 4n. Now I'm going to take this second term, take this second term, it's positive 4, so I'm going to distribute it. There's the O, the I and the L inside and last for FOILing. And this will be 4 times 4n is plus 16n. And then plus 4 times 4 is positive, they're both positive, so the product will be positive 16. So there we go. This is our product of those two functions. And I'm going to simplify it by combining like terms. So here we go. This will yield 4n plus 16n are the only terms that can combine. They're both n terms. N squared won't combine with n because in order to be like terms, they have to have the same variable, which they do, and the same exponent, which they don't. So these two won't combine, but these two will. With that in mind, I'm going to combine them. This will equal 4n squared plus 20n plus 16. And that's g of n times f of n, or g of n times h of n, or g times h of n. There we go. That's what we would be looking for in our standardized setting. And I think somewhere around here I have got the key, the answer key. So let me take a look and see if I do. I do. 4n squared plus 20n plus 16. 4n squared plus 20n plus 16. So I just took this function, I took that function, I multiplied them together because that's what I was asked to do. I FOILed. First, outside, inside, last, combined like terms, and there's my product. That's the product of those two functions. Here's another one. Let's go ahead and run through it real quickly. We're going to do the exact same thing. We're asked to find g of n, or we're given g of n and h of n, and we're asked to find g times h of n. And again, this could be written g of n times h of n. This could be represented like this. They both mean the same thing. With that in mind, I'm going to go ahead and say that g times h of n is equal to g of n times h of n. N cubed plus n squared is g of n. And h of n is 4n plus 2. I'm going to FOIL again, combine like terms if there are any, and then I'll be done. So here we go. I'm going to bring my equal sign down here. And this will give me n cubed times 4n, n cubed times 2. N to the third power times 4n is 4 times n times n times n times n, or 4n to the fourth. When you multiply like bases, you leave the base the same and add the exponents. That's 3, that's an invisible 1, n to the fourth. Then I'm going to take n cubed and multiply it by 2. That'd be 2n cubed. Whoops, I said 4 and I wrote 3. Brain damage. N to the third power times n is n to the fourth power. 4 times n to the fourth. Plus 2 times n to the third. I took this and I multiplied it by 2. Now I'm going to take n squared and multiply it by both of these. That's I and L if you're FOILing. Some people think of it as double distributing. Distribute this one, then distribute that one. That's fine also. N squared times 4n is positive because they're both positive. 4 n to the third power. And n squared times 2 is positive 2n squared. If I haven't made any mistakes. And now I'm going to see if I can combine any like terms, if there are any like terms, and then I'm going to combine them. First I'll see if I have made any mistakes. I'll check that. N cubed times 4n is 4n to the fourth. N cubed times 2 is 2n cubed. N squared times 4n is 4n cubed. N times n. And n squared times 2 is 2n squared. So I don't believe I've made any mistakes. I see a couple of like terms I can combine. You can only combine like terms. Terms are like if they have the same variable and the same exponent. These are the only two that can combine. They meet the definition of like terms. With that in mind, we have 4n to the fourth power plus 2n to the third plus 4n to the third. That's 6n to the third. We're just combining like terms. It's not we're not going to add these exponents. Just this tells us how many of them we have. Plus 2n squared. We can't combine any terms any further, so there's what we're looking for in a multiple choice scenario, right there. And this is equal to g times h of n, which is g of n times h of n. All right, let's take a look at the next ones. I think we'll be dividing functions. Yes, we will. We're given a g function, we're given an f function, and we're asked to find g divided by f of n. And that could be written g of n over h of n. It could be written like this. They both mean the same thing. We're going to take the g function and divide it by the h function. Oh, I'm sorry, the f function. Getting old, my brain's slipping. There we go. So I'm going to take the g function. I'm going to say g over f of n is equal to, and the g function is 2n minus 3, so it'll be this over this. 2n minus 3 over 2n plus 1. And once I've got that done, I'm going to look to see if I can factor either one of these, and if I can, I'm going to factor it. And if there are any common factors, they're going to cancel each other out. I look at this, it's a binomial. They don't have any terms in common, so I can't factor out a 2, for instance, or a 3, because they don't both have a 2 or a 3. So the top won't factor, neither will the bottom by the same logic. So we can't go any further. I'm just going to leave it just like that. And I would be looking for this part in a multiple choice scenario. G over f of n, or g of n divided by f of n. Okay. Let's take a look at the next one. We're asked to find h over g of x. H of x is given as 2x. G of x is given as x squared plus x. So we're going to do that, see if we can factor anything out, and then cancel common factors if there are any. That's whenever we're dividing, we always want to see if either the numerator or the denominator or both will factor, and if they will, factor them and see if you can cancel common factors. So here we go. I'm looking for h over g of x. H over g of x is 2x, that's h of x, over x squared plus x. Now I'm going to see if I can factor this. As I did with this one, I looked to see if either one of these would factor, and they wouldn't, so I was done. I look at this one, that won't factor. It only has two factors, 2 and x. It won't factor any further. I look at this one, both of these terms have an x in them, so I can factor an x out, and that's what I'm going to do. I'm going to say, well, this will equal, the top will remain the same, 2 over x. The bottom, if I pull an x out of both of these, I write what I'm pulling down, or what I'm pulling out as x, and then term by term, I pull that x out by dividing it. If I divide this by x, I'm left with the other x. Plus, if I divide this by x by pulling it out, x divided by itself, anything divided by itself, with the exception of 0, is 1. So I've written down what they both had in common. They both had x to the first power, 1x in each case. And then I open a parenthesis, and term by term, I pulled that x out. And to test to see if I factored it correctly, I can distribute this in my head and see if I get x squared plus x. X times x is x squared. X times 1 is x. So this and this have the same value. The reason I factored them is because this can now be simplified, because I see that this and this are common factors. We have the same factor in the top and the bottom of the fraction, and we can reduce by canceling common factors. They have to be factors. You can only cancel common factors. You can't cancel across plus or minus signs. This is 2 times x. This is x times x plus 1. So this x will cancel. And we're left with 2 over x plus 1. That's all that's left in this case. And that is h of g of x, or h over g of x, which is h of x divided by g of x. Another way of saying that. So here we go. And that's what we would be looking for in a multiple choice scenario. We would be looking for that. Okay. So that's what we were doing. Performing operations. In this case, the operations were multiplication and division. We multiply. In each case, we were given binomials, but if you're given anything else, you just multiply them. And because they were binomials, I FOILed, then I combined like terms if there were any, and there were. And then once they were combined, I was done. With dividing, you just take the one that's denoted as the top function, so to speak, put it on top, the other one on the bottom, look to see if you can factor and cancel. This one wouldn't. This one, I said, hey, that will factor. So I factored out an x, canceled those x's, and was left with 2 over x plus 1. Performing operations on functions. You can do this.